Hello and welcome to another episode of Math with Martinez. We are in part 2 of our discussion on piecewise functions, and we are looking at graphing them and finding out if we have any discontinuities. So let's go ahead and begin here with this example. We're asked to graph each function, then give the domain, range, and identify the location and types of any discontinuities. Now, you can definitely graph each of the pieces, which I'm going to go ahead and highlight here in just a little bit. You can definitely graph each of those pieces as separate functions in your graphing calculator. But I want to introduce you all to a really cool calculator that you have access to anywhere you have internet connection, and that is the Desmos graphing calculator. So I'm going to go ahead and begin to graph those here and show you how to correctly enter them on Desmos. All right, so our first piece of the function was the absolute value. Let me just move this out of the way for a minute. It is the absolute value of x plus 3, and then outside of the absolute value it is minus 1. But we have, let me go ahead and highlight that in purple so it matches. We have this restriction on the domain for this piece of our piecewise function. It's kind of like a Frankenstein function where we have all these pieces put together, and something new and kind of crazy looking is created. So appropriate for this month, am I right? Okay, so we're going to restrict it to x values less than 0. Here's what that looks like. Go ahead and click this button down here that says ABC and get the set brackets, because we need to say that this graph is only going to include the set of x's less than 0 as specified by the domain for that piece. So what we're seeing here is this absolute value function that stops when our x's are at 0. So it stops at that height of 2 and does not continue anymore. Now let's look at the other piece. The other piece is 2x. And so I'm graphing this separately as a separate equation. Let me get a better color here. I'm going to go orange. Okay, and now if we look back, so this one right here, this orange graph, is when x values are greater than or equal to 0. So let's go ahead and specify that. We want in the set, so click ABC, go to the set brackets, and we want x is greater than or equal to 0. And so there you have it. That is what our graph will look like. It's got some of these critical points here. Let me highlight them. And that one. So these are two pieces in our piecewise function, and let's go ahead and go back and sketch that on the coordinate plane. So our purple piece, it started at a height of 2 right here, but at this value here, it is an open circle because when x is strictly less than 0, that means we need to have an open circle at that value of x for our purple function, open boundary. Then it went down, and it went down, yep, to right there. When x was -3, y was -1, and then it went back up at a slope just like so, and continued off in that direction. The orange piece was down here at -5, so 1, 2, 3, 4, -5, but this we want it to be closed because look, it should be closed, it should be included for the orange graph at that value when x is equal to 0, and then it went and also crossed at 2.5. It went up 2 over 1, up 2 over 1, up 2 over 1 in that way. So looking like this. So there you have it. The graph of our piecewise Franken function. Now let's identify what would be the domain, that is our x values. What kind of x values do we have here? Let's read from left to right. Beginning on the left, well, I'm seeing here that it does keep going forever in the leftward direction. So it keeps going forever. So that means to negative infinity in that direction. And then if I continue tracing, we do have this open value here, but it is defined down below, so we don't miss anything at 0. We still are there, and it continues to the right forever. So this goes all the way to, all the way to infinity. So you could write this using the interval notation, or if you want to write this using set notation, it would be all real numbers. So either way you want to write that, perfect. Now what about the range? For range, we want to read from bottom to top. So what is the lowest our graph goes? Reading it from down here, what's the lowest? Oh, it looks like it's right here. This value, that lowest y value is at -5, and it is included. So I'll put a little bracket around that to show that it's included value. And as I continue to read up, okay, yep, it's defined there at a height here, yep, defined. Yep, it is still defined, and it keeps going up and up forever and ever. So this means that the range is going then to positive infinity. We could also write this using the set notation that it is y values such that our y is greater than or equal to -5. And we do have a discontinuity here, don't we? What kind of discontinuity is this, ladies and gentlemen? It is a jump discontinuity. We have this jump discontinuity, and at what value does that happen? That is at x equaling 0, right where those two pieces are coming together. We see that it is not coming together at one point, but that they are broken apart. And so, ladies and gentlemen, that is what I wanted to show you here in regard to our piecewise functions and their graphs. Being able to graph them, and definitely make a note to yourself to use Desmos here to help yourself out. And then identify those discontinuities. Do the two pieces of your Frankenstein function come together and join up? Or do we have two disjointed pieces like you see in this one? That is all for this video. If you guys had any questions, will you please take a moment to share those now? And until next time, stay fired up.